Hi, this is Kulpreet. I'm the CEO of Chiltier, based out of Hyderabad in India. So the first part of our system is the Chiltier t-shirt. This would be provided as part of the system. The second layer would be this fabric. I know this fabric looks very nice. It's beautiful, it's golden. However, that is not its main purpose. The reason why we have this is because this is known as a Faraday cloth, and this is known to have the highest thermal conductivity of any fabric that is available commercially or otherwise. The third and the most important part of our wearable is this vest. Right now, the tubes are exposed simply because we want to show you what they look like. However, in the final version, the tubes will be covered by the Faraday cloth, and this is what we would use to keep the equipment generally clean, because this is easily washable and is also wipe down friendly. The tubes themselves have, again, a thermal conductivity of upwards of 5, both through and across the plane. These tubes have been manufactured by us using our proprietary methodology, and they are amongst the highest thermally conductive polymer tubes that are available in the market. The reason why we chose these tubes again is because we want to have as little thermal resistance within the system as possible, and these tubes help us to achieve that. They are connected with dual port connector. This connector is in essence a closed loop, no leak connector. So you can connect and disconnect multiple times. You will not lose more than a couple of droplets of water. So therefore the system doesn't need to be refilled repeatedly. We have these dual port connectors, which I will show you how to connect. They show you where to align, and you have to just snap fit the system shut. On the other side, we connect it to our box. Again, right now we will be using the same methodology, but going forward, one side will have the dual port connector as before, but the other side will have a magnetic connector, which upon application of a certain force, such as if unfortunately a rider comes off a bike, it will automatically disconnect and it will keep the rider safe. So this is the Chiltier box. This is the heart of the machine. This has peltiers, of course, because this is a solid state cooling mechanism. It also has our proprietary designs for heat extraction, so that the temperature inside the box can be maintained at no more than a couple of degrees over ambient. This box then cools the water. The water circulates through this tube. It goes into the vest. It exchanges heat with your body. It then is returned, where it is then further cooled and brought back into the jacket. The last bit, which I think is equally important, is the concept of a microclimate. So this is our Chiltier brand gilet. We also have a full sleeve jacket made of slightly insulating material. When you wear this over the vest, it creates a microclimate, which then allows the vest to exchange heat more efficiently without being bothered about ambient temperature. Now that the tube is connected to the box, all we have to do is switch it on. Once the water reaches an acceptable temperature, which can be preset or it can be determined automatically by the sensors within the vest, the water starts flowing, and hopefully we should be in the thermal imaging camera, we should be able to see how the temperature of the tube is changing. The minimum preset that we have is 14 degrees. We don't recommend going below 14 because it would act differently on the skin. It would in fact cause vasoconstriction, which would be the opposite of what we need. So we need the temperature to be within a range that is extracting heat, yet is not triggering your body's natural mechanisms to conserve heat. I think you should be able to hear a little bit of the noise of the system, which, as we have mentioned, is just below 20 decibels at 1 meter space and would not make you uncomfortable. As I have mentioned, it's merely 800 grams. It's not very heavy. It's very silent, under 20 decibels. We use solid state cooling, and there are only 2 equipments which has moving parts inside this. The PCB is housed in a separate unit, which is completely waterproof. Because of this, our box will be getting an IP64 rating. We have already started work on that. We are trying to make this a little bit smaller as well. This is not the final prototype. We have an interim prototype, which I would like to show you. This looks a lot better. It is a little bit more finished, but this is still not our final box that we would be using. That would be a carbon fiber box. At the rear of the box, you can see mounting, which we have mounted purely for testing purposes. The idea, because of its weight, is that we do believe that it can be mounted in most places quite easily, including the side pannier, even by the side of the fuel tank. The only thing you need to be careful of, that it should not be near the engine. Obviously, that's not optimum. And another thing which you need to do is to have about 2 inches of clearance on both sides for air to flow within the system so that it can be cooled. We have tied up with one of India's largest drone battery manufacturers, a company called Magni Power, who will be supplying our battery systems. The heaviest that we expect our battery to be would be close to 1.2 kilos, and that would be capable of operation of up to 6 hours. We wanted to demonstrate the hot mode. I have set the temperature to 40 degrees Celsius, 104 Fahrenheit, and hopefully through the use of the thermal camera, you should be able to see the pipes are heating up. Right now, the water temperature is at 29 degrees, which is 11 degrees short of our desired goal, but that should be reached within the next 120 seconds. We are quite far along with the development. We are working on the battery management system so that we can optimize the battery usage to make sure that it lasts as long as necessary. We also are working on our PCB. This PCB would again be optimized not just to control the temperature, but to also receive information from the wearer, from the various sensors that we have in place to compute and to give us the best possible function given the ambient temperature, given the core temperature, and given what we are sensing from within the microclimate. Our Z1 version, which is a backpack mounted version, it will be very similar in terms of function to this. It's only the form factor that will change. We will be making it vertical and mounting it on a backpack, and it will have airflow from 3 sides, 2 sides for air ingress and 1 for the exhaust. So that system is actually a little bit more efficient than this one because it has better airflow. So again, we are trying to make it smaller, we're trying to make it lighter, and also we're trying to improve its functionality.